Welcome to the SPSS tutorial video on interactions and simple slopes analyses in multiple regression, also known as testing for moderator variables. In this video, we'll go over how to create interaction variables, how to interpret interaction terms in a regression model using simple slopes analyses with continuous variables. You can also perform simple slopes analyses with categorical variables with a slight variation on the procedures shown today, but today we'll only cover continuous interaction terms. The data we'll be using for this exercise are a data set about age and exercise. The data set began with three variables: age, exercise, and endurance, where we wanted to predict endurance on a running test from age and exercise as well as their interaction. To create an interaction term, the first step we have to do is center both age and exercise. Here I've indicated the centered terms by placing a C in front of the name of each variable. If you don't remember how to center variables, return to the video on recoding and manipulating variables within SPSS. In this case, I've already centered both variables, and I've already created the interaction term as the product from the two centered variables. That is, to create this interaction term, we would go to the transform menu and compute, and we would multiply centered age times centered exercise to create this interaction term. It would be incorrect to multiply the first variables, age and exercise. Instead, to create the proper interaction term, we must multiply the two centered variables to create the proper center interaction term. Now, to run the regression analysis with moderation, we go to Analyze, Regression, and Linear. We then choose endurance as our dependent variable. We choose over our center age predictor as well as centered exercise and the centered interaction between the two. We can click OK, and as we scroll down, we see that in this case there is a significant interaction between age and exercise. We see that age is a significant predictor of endurance. Exercise is also a significant predictor of endurance, but there's also an interaction between these two variables. Based on these statistics alone, though, we don't understand the pattern of this interaction. And it's the reason for doing simple slopes tests is to understand this pattern. If we return to our data, you'll see that I've also created 4 new variables. Each of these variables was conducted in order to run our simple slopes tests. We need to run 2 more analyses in addition to the one we've already done in order to interpret our simple slopes. The way we run these analyses is to determine which variable is our predictor and which variable is our moderator variable. In this case, we're going to choose exercise as our moderator variable, though we certainly could have chosen age as well. To run exercise as our moderator variable, the first variable we need to create is a variable where exercise is low. To create this variable, we would go to Transform and Compute. We would then compute low exercise as the centered exercise variable plus 1 standard deviation in exercise. It sounds paradoxical to create a low variable by adding 1 standard deviation, but I promise you that it's true. We create low exercise by taking the centered exercise variable and adding 1 standard deviation. We then compute the interaction between low exercise and centered age to create this centered age times low exercise interaction. Next, we create the same types of variables with high exercise. Instead of adding 1 standard deviation, to create the high exercise variable, we subtract 1 standard deviation from the centered exercise variable. Again, if you're unfamiliar with how to manipulate and create new variables in SPSS, please return to the video on manipulating data. We create this high exercise variable as well as the interaction between high exercise and the centered age variable. As you can see, I've already created each of these variables. We next run the simple slope for when exercise is low. Under Analyze and Regression, we choose Linear Regression. We maintain centered age in the analysis, but we choose over low exercise and the interaction between age and low exercise. we can now run this model. When running the model for simple slopes, we ignore the overall model statistics because the only particular thing we're interested in is the effective age when exercise is low. In this case, we are not interested in the parameter associated with low exercise or the interaction term. These are simply manipulated variables that we've used to examine the simple slope of age. We can now interpret this coefficient, which is significant, as the effective age on endurance when exercise is low. That is, for people who don't exercise very often, their age has a significant effect on their endurance. Let's examine the results when exercise is high. To do that analysis, we use Analyze, Regression, and Linear. Instead of using low exercise and the associated interaction, we pull over high exercise and its associated interaction, leaving the age term the same. Now we run this analysis, and what we notice is that the coefficient associated with age is no longer statistically significant. Again, we ignore the coefficients for the high exercise variable in the interaction. What this model tells us is that the effective age on endurance is not significant for people who exercise a lot. Now this helps us interpret our original interaction term. As I scroll back to our original interaction analysis, we found a significant interaction between age and exercise, but from those numbers alone we didn't understand how to interpret it. By using the simple slopes analyses below, we found that age has a significant effect on endurance for people who do not exercise often, but age is unrelated to endurance for people who exercise a lot. We now understand how to interpret this coefficient for the interaction, and that's the purpose of simple slopes analyses and regression. As I said before, we can repeat these same steps using categorical data. The interpretations change slightly, and your instructor will cover that in class if you need to learn that. But the same basic steps for computing high and low interactions remain similar to interpret simple slopes or moderating variables in regression.